1, 2. Let's go to, all right, so let's go directly into, okay. The first thing you need to do, guys, the most important thing, basically, everybody has a blank piece of paper like this, right? The first thing you need to do is go to project, edit, and we need to, huh? Crashing, okay. Okay, let's go gen size, generator default. This is your default. Well, actually, before you, can you guys click, make sure the new project is highlighted like this? New project. Everybody. Then go to project, edit selected project parameters. Everybody can see that? Selected project parameters. When you get into the project, we're going to call it industrial project. This is your industrial project. And you can put any comments you want here. This, you guys have to fill this information here later on, but at least industrial project. Then go to the parameters. When you go to the parameters, I would like you guys to put 2 generators, because I know if you run with 1 generator, it kills you, exceeded the limits. From the get-go, let's put 2 generators. Cool? Okay, so I have 2 generators. I'm paralleling 2. All these are default. The voltage is 480, 277, 3-phase, diesel, 60 hertz. Everything else is default. What's the altitude that we have in Minneapolis here? 1800?
No.
No?
Mine's point in Minnesota is 1200.
1200? You think Minneapolis 1800? I thought it's 1700. Now, not 18, I mean 800. I'm sorry. How much? 600. Let's put 686. Thank you. Here's my elevation, 686. Temperature, everything else stays the same, guys. Cool. Everybody's good with that? Standby. So everything that we size is standby. We don't size for continuous or prime. If you guys remember when we went to Cummins, when they say prime means they run. Standby, they run a couple of, they basically run, I think 100 hours or less a year. That's what the standby is. Then if you go prime, they run more than that, and continuously. So we're running standby. Everybody got that one? Okay yet? Then, next. So we got the parameters of my generators. The next is the steps. Here's what you need to go for the steps. I'm going to go minimize this. I'm going to put it right next to my my Revit. If I can get it here. So the steps that we were talking about, guys, so many softwares. Okay, so the steps that we need is basically the steps that that the switchgear is having. So let's look at the steps that we have here. The first and the most important thing in our system is the emergency panel. So the first load is going to, step number 1 is going to be what? Your emergency load. So let's count them, by the way. I have my emergency load here. The next important things, emergency, we're going to go to UPS. So what the step means, guys, when you start your generator, we're going to turn the emergency light on first, then the UPS second, then, so I'm going to go emergency first, then UPS, then lighting, then receptacle, then mechanical 1, then mechanical 2, then bus 1, then bus 2, in this order. Okay? So that's, let's go back and start with my steps here. So I have my step number 1. I don't know if, and no rename. Okay. So here's my step 1. Step number 1, I will need the emergency load. Emergency load is lights. So if you guys remember where, here's my light. Click on lights. I'm going to call this is emergency EP, emergency panel. And the KVA on the emergency panel, what was the KVA, guys? Go KVA. Was it? I doubt it's going to be more than 5 KVA. A couple of lights. You know what? Let's put 10 kV on it. Doubt that it will be more than that. Much emergency panel, just a couple of lights on it. The voltage is 480 3-phase, right? It is 480 3-phase. Type of that we did is we have only option fluorescent, incandescent, discharge. I'm going to choose fluorescent. That's the closest to what I need. Everybody's good with that? Go to next. Next, it will get you the power factor, default, and finish. Load number 1 is my emergency. Can I have thumbs up, Chad? So grab, then you grab it. Can you see I'm holding it, guys? Grab it and throw it on step number 1. So now emergency load is set to start at step number 1. Can I have thumbs up, Chad? At any time, you can come and double click on it and edit the load to add it, to modify it. You can put it in kVA, in kW, on amps at any time. Everybody get that one? Did it go too fast on that one? Okay, step 2. To add a step, guys, can you see where it says the arrow here? Add a step. Here's my step 2. What was step 2? Step 2, I said I'm going to put my UPS system. So here's my friend. So here's my step 2. I put step 2. Where's my? There is a UPS system here. Okay, here you go. You uninterruptible power supply. So Aaron, what was the size that you guys came up with? Click on that one. I'm going to call it UP. Now, remember, guys, when I say UPS, can I get you to understand that's the 2 PDUs and the UPS all lumped sum in one big fat feeder? Everybody understand? No PDUs. The PDUs will be lumped summed into the whole UPS size. Okay, so I'm going to call it just UPS. What's the kVA that you came up with? 375. Everyone is going to use their own. And it's 482.77. Why 482.77? Because the PDUs were 208, but I'm lump summing them in one feeder, right? Because I'm going to turn the whole feeder on and off, right? So it's 480. It defaults to 6 rectification, guys. You can go to a 12 rectification. The more rectification, the better the system would be. So I will default to 6 rectification. How they rectify? UPS is AC to DC, right? So they're doing DC here. So I will default to this one, go back to here. Next, it will give you all the power factor and the efficiency. Unless you know otherwise, what do? Take the default and finish. Here's my UPS load. After you're done, grab the UPS and throw it on step what? Step number 2. Can I have thumbs up, Chad? Done. Step number 3, add another step. What was his step number 3? What did we say step number 3 we're going to do? Lighting panel. Oh, here's light. Click on light again. I'm going to call it LP lighting panel. Put kVA. Okay, what was the size, Aaron, your kVA on your panel? The actual size, not the kVA that you guys came up with. You guys, this will come up from your calculation. So if I go, Joe, and I check your calculation and you're using his, so this should match your calculation that you did in Excel. 108, 108 or 180? 108, thank you. 108. 108 kVA. It's a 480, right? It is a 480. And what's the default is fluorescent. I know we did incandescent lamps, guys, but I don't have an option. These are the 3 options that I have. I bet you if you go online, they'll give you the option for, so here's my 3 options. The closest to what I picked is fluorescent. And then finish. And that's my LP. I'm going to grab it and drop it where? L3. Now I have my lighting panel on step. Everybody knows what a step is. A step is the generator comes up within 10 seconds, picks load 1. Another 10 seconds, pick load 2. Step 2. Another 10 seconds, pick step 3. That's how they do them. Like when they were paralleling. These are the priorities that I want to pick my load in this priority. Can I have thumbs up? Everybody's okay with this? Made a mistake. Joe made a mistake. Come back to lighting. Say if your lighting was 120, you just go type 120 there. Cool? Next, I didn't go to the next. You take the default for the power factor, guys. See where the power factor is default and finish. Everybody has 3 loads. What's next? What did we say? We're gonna another step. What is that? Receptacle panel. Okay, so the receptacle panel. We have miscellaneous, we have fire pump, we have motors, we have medical, we have all this stuff. I usually use miscellaneous. Okay, general receptacle. Everybody can see the general receptacle here. Grab the general receptacle. Cool. Next. Okay, now, what's the voltage on the receptacle? 208. Right? So type the voltage. And what was the kVA that you guys calculated for your receptacle from your load calc? 26 kVA, 46, 46 kVA. Now everybody has their own number. and your number will be as accurate as this information will pick.
You can rename that, right? So I can-
I'm sorry, it's going to be
Connected load.
RP.
I'm gonna go on the load calculation.
RP. Everybody guys name the RP receptacle panel. Made it 208 3-phase, and the kVA I'm using, or kW, they're using kW or kVA, and we're using this. If you go to next, it default to a power factor of 0.9. That's okay for me, unless I know otherwise, and exit it, then grab it and drop it on step number 4. Did you guys hear me? We don't go by the panels that we did. We go by the load calculation. Okay, that's the most accurate. Remember how the panels, we kept going up in all the panels? Go by the actual load, that we calculated. Cool? Okay, what's next? Step number 5. What did we say we're going to put step number 5? Mechanical. Now that's where it's going to be interesting. For mechanical panel 1, guys, step number 5 is going to be mechanical panel 1. So now what's in mechanical panel 1? What type of motors? We're going to go grab mechanical panel 1. For mechanical panel 1, because it has a lot of motors in it, we're going to use the actual motors, because there's a lot of motors in it. Okay, so let me give you a sample. For example, mechanical, let's go, Jeff, mechanical panel, give me a load that's on mechanical panel 1, will you? Yeah, one load, motor load. Click on motor. I'm going to call it, give me one load, horsepower, that's on mechanical panel 1. Let's pick the largest. What? Is it a horsepower? Give me is chilled water pump. I'm going to use the chilled water pump, guys. It's a CH. I'm going to call it CHWP -1. CHWP -1.
30 horsepower.
-1. Thank you. Chilled. This is my chilled water pump. The horsepower is 30, and it's a 480. What's the starting mechanism on it? Can you guys see from the sheet? This sheet, it will tell you this baby has a full voltage non-reversible. That's across the line. Okay, so let's go to its standard NEMA. Can you guys see that? It's a standard NEMA. That's full voltage non-reversible. Does it have a VFD on it? No. Okay, so take this. You're up high efficiency design. We have no idea if it's high efficiency. So you're either VFD, and when you have VFD, guys, we typically go pulse width modulation, or any one of them really. If it's not, it will be a standard NEMA. Standard NEMA. Next, across the line. Can you guys see that? Your options are across the line, Y delta, part winding, resistive, auto transformer. Do you see anything on the control here about any of these? So what's your default across the line? Just a magnetic starter. Do you see the locked rotor current for the motor? Did we give you the locked rotor current? No. So what do? You take a default. Everything here is default. Finish. Here's my chiller. Here's my that's start. Yeah, that's, look, if you go back, next, where's my power factor? Here's your power factor, 0.8. This one is the start power factor. When you start, it's very low. Here's your actual power factor running, 0.89. Good point. Finish. Okay, then I'm going to grab this motor, and guess where I'm going to put it? Step number 5. Every single motor.
So all the motor loads for MP1 can be on.
Step number 5.
And then all the motor loads for
MP2. Thank you. I'm not going to go over all of them. I get you one. Can I go, guys, to step number 5, and you get the rest of it? You're going to add all the motors in it. Step number 6. Step number 6, mechanical equipment 2. I'm going to go motor again. I'm going to go to air handling unit. I know air handling unit dash R1. Okay, so this one, guys, air handling unit was 25 horsepower at 480, right, Jeff? 25 horsepower at 480. VFD Why did I pick VFD for this one? It says VFD here. Huh? Yeah, it says VFD. I'm going to go pulse width modulation, guys. The two options that I have. See what I picked? VFD, pulse width modulation next. Here's my default from the system, and here's my air handling unit. I'm going to go and put it at step number 6. Done. So everything, every single motor load that's on MP2 is going to be under step number 6. Can I have thumbs up, Chad? We understand that one? Okay, let's go to step number, do you mind? You guys will, step number 7. What was step number 7? Do you remember chiller? There was a chiller directly related. I'm going to go pick up the chiller. Chiller, here's my chiller. Here's my chiller. I'm going to go, how did we specify the chiller? Chiller CH1, CH-1. Can you guys see that one? This is my chiller. What was the ton of my chiller? What's the kVA? 525. So here's what I would do. I start, can you guys look at the kVA here? And let me see if, okay. Can you guys see, look at that? My running kVA here is what? I'm looking at 525. And if I put 500, it give me 8, so it's definitely less than 500. So I'm going to go, can you guys see that? Let me see, 400. Thank you, 300, 523, 25, maybe 302, maybe, to be precise. Okay, 301, thank you. Everybody knows why I came up with 301 ton, because when you run it, it gives you 524, and I'm looking for 525, very close. Everybody can see that? So what's the ton? Everybody got that one? Most likely, guys, if it's division, it says chiller division 15, I will put a VFD on it though. But a VFD, guys, on the chiller, 99% of the time we'll have VFD. And pulse width modulation, I know it's not saying it there, it says by others. Put a VFD on it. Pulse width modulation, 480, 3-phase, everybody's there?
It's changed your kVA.
It changed my kVA.
550.
Running kVA 550. If I put it across the line, how much, what's the difference? I wouldn't worry about it. I wouldn't worry about it.
285 with the VFD, it runs at almost 525.
Yeah, you can run it a little bit higher. So I would stick with that one, guys. Typically, you have the tons from the mechanical engineer, so you don't have to play the game. So we got that one. Everybody got that? And we're going to use pulse width modulation. And next, here's your default. This is all your default, and finish. Here's, I went to pulse width, yeah. And finish, and then I'm going to go grab it and put it on step number 7. Can I have thumbs up, Chad? Cool. You know what? It really doesn't matter. After you put your emergency and UPS and lights, really, you can put any step at in any order. Okay, let's go step number 8. No, the chiller was this symbol. Air conditioning load. Cool. Okay, let's go, guys, to step number 8. Step number 8 is busway. My busway. So for my busway, because there's so many things for busways, I'm going to size it with kVA, guys, the busway. I'm going to go to, let's just go to this. Click on that one. User defined. I don't know if I'm going to mess with user defined. Next, let's call this is busway, bus duct to, let's use the 480 first. 480, cool. 480. Now, can you give me what the kVA on the busway, the kVA from your load calc, Aaron, about your busway, the 480.
KVA is
1,000. Are you sure this?
no.
That's
KVA,
it.
sorry,
660. Okay, 660. Starting capability Now, because it's user defined, guys, they want you to do the starting capability. Um, I'm going to double this. Usually, it's the starting capability is it goes from 2 all the way to 6 times. So I'm going to use what's 2 times 666? 1320. I'm going to start 30 because it's user defined. I have to get in mess of all this stuff. Okay, then next, power factor 90 is good enough for me because I have capacitors. Okay, so I define it. Everybody's good, and I finish it. Here's my bus stock number 1 is going to be on step number 8. Okay, step number 9. Step number 9, guys, I'm going to go the same thing, bus stock, the second bus stock here, user defined. Next, who's my friend here? Aaron, what's this? I'm going to call it bus duct 208. Oops. What's the KVA again? 152 KVA. Again, you guys are going to use your own. I hope I wouldn't see these numbers in your calc. You're going to use your own numbers. Remember, this one is 3-phase 208 though. 208, right? There was a 208 system. I changed it. I'm going to double this one, so that will give me 304. Double this. Why did it double it? The start is usually 2 up to 6 times more than the run. That's typically the start. How would I get this number, guys? Typically, talk to the manufacturing engineer and say what the starting capability, and you adjust this slightly. Okay. Next, power factor default 90 is good. Okay it, and grab that son of a gun and put it under 9. What's left? Yeah, you guys have to add all the motors for the busways and all the stuff. Do we have anything else left as loads? So we have step 9. Do we have anything else? Am I missing anything? Oh, here. Where's the state of guessing? Here's all my here's my receptacle, my mechanical panels, my lighting panel, receptacle panel, emergency chiller, UPS battery, all this junk. We took care of them at once. And here's my 2 bus ducts, and here's my mechanical equipment at the top. And those guys have two receptacle panels. We lump sum them as one load. Okay. Now, when you're done, not now, you're going to go run. So we're done. Let's go run. Running is this little deal here. Go run. I have 2. Now, my size of my generators is 1,000. Can you guys see 1,000 kW generator right now? As of now. Here's the size of my generator. All the information that I need. How many generators? Can you guys see at the bottom here? Everybody can see at the bottom. How many gens do I need? 2. I need 2 gens, 1,000 each. Here's my load. Here's my generator configuration. And when you're ready to print reports, here's the reports that you want. Your steps, all your steps that you've done, that you're going to print to your friend Chad is under steps. Cross that one. And you're going to come here, reports. All the generator recommended report. Here's my gen recommended report. 2 reports. One generator recommended report, and the other one is going to be the load steps. Again, I'm not done. You guys, what you need, then you go back to your, here you go. So what you need to go, guys, under step number, which step? Step number 5 and step number 6, you have to fill more info. That's it. That's your gen size. When you're done, here's what you need to do when you're done. You're going to take, say you came up with 1250. You're going to take it and type in Revit 1250 on the generator, KW, and you need to go back and size the feeders based on 1250 for generator. How do we size it for generator? Do you guys remember the sheet that I gave you? How to size the feeders and overcomputation device? Basically 1.25. You're going to resize the feeders after you come up with the size of a generator. Can I have thumbs up, Chad? We understand? Yes, no? Is this enough? Heating load, no, air conditioning is different than heating load. I would use user defined and just put it as 100% heating load. Yeah, heating load, guys, the only thing that you do air conditioning is just a chiller. Almost everything is going to be motors. or receptacles or lights. If it's not any of the above, you can use user defined and make it user defined and just double the value like we did. Any comments, any questions? That's it. That's your generator size. Okay, calculation. All right.